So you're going to get started learning to deal with basic mixtures. And the first question that comes up is, why would you learn something like that? Well, one of the ways you can think of it is stuff gets combined all the time. You're mixing a certain amount of one thing, a certain amount of other. That happens all the time. And this example, there's a greenhouse that you're seeing here, and you might end up working at the greenhouse, and perhaps you've got to mix two different kinds of fertilizer, and one doesn't have enough concentration of phosphates, one's got too much, and you need to mix them together to get the right amount. And so, that does happen, and I want you to be prepared for that kind of thing, and also just have understanding of some basic mathematics, and this is part of it. So I want to move you forward, and we're going to start with this idea that's kind of like this. If you've got some orange juice that's 30% juice, or another one that's 60% juice, and when you mix them together, the result depends on how much of each of them you mix. If you use just a little bit of the 30%, you're going to get a mixture that's pretty close to 60%. Okay, but if you use just a little bit of the 60%, then you're not going to raise the concentration of the 30% very much. So what we're doing kind of depends on how much of it you're talking about. And this idea that we're going to be looking at applies to fertilizers, populations, even investments, might be metal alloys, just all sorts of different things that you can use this mixture idea for. So to get started, I want you to think about a liquid in a container. This is maybe a 1 quart jar, and we filled it up and let it sit there. Well, some mixtures will separate when you let them sit. Here's an example of some Italian dressing from my cupboard, and I tried to tear the peel off. I'm sorry, the paper off there a little bit more so you could see the oil going all the way to the top. But it's been sitting there a long time, and so all the oil on top is separated from the water down below, and of course the water's got some spices and things. And I want you to think of mixtures when you think of taking a liquid with something mixed into it. I want you to think of it as having kind of separated out. So if you look at this jar here, I try to tip it back. Okay. So here's the same jar, but I let it sit there for a while, and now the heavier stuff is down at the bottom, and the lighter stuff is sitting up on top, and it's separated out. Well, we're going to be thinking of liquids and other mixtures that way. So I want you to imagine that you've got a 32-ounce can of paint here. Okay, so we're going to write in here, this is 32 ounces. Okay, and it's 20% paint. So you got this amount right in here. I think maybe I can even shrink that down so it looks like 20%. Yeah, it's just a small amount there. So 20% down here is actually pigment, okay, which means 80% up above here. Whoops. Okay, and so here's the question. How much pigment is in there? Well, it's 20% of 32. So I'm going to write that, 20% of 32. And you may remember from your previous areas of mathematics here that to find a 20% of 32, you take the percent and multiply, or make it a decimal, and multiply by the number. So 0.2 times 32, and your answer ends up being 6.4. Okay, when you calculate that. Okay. So there's 32 ounces of paint, but 6.4 ounces of pigment. Okay? So what about a 40-ounce can that's 12%? Okay, so this one's 40 ounces and 12% pigment. Okay, and another one that's 40 ounces that's 30% pigment. Okay, now our question is, how much pigment is in there? Well, what we're going to have to do is figure out how much pigment is in the first amount here, and how much pigment is in the second one. Okay, and then add them together. So let's calculate these up here. Okay, 12% of 40. Okay, that's going to be 4.8. Okay, and 40%, nope, excuse me, 30% of 40, that's going to be 12. So how much is their total? Well, we'll just add them together. 4.8 and 12 gets you a total of 16.8 ounces. Okay, so again, what we ended up doing was taking the amount of pigment in each one and adding them together. Okay, so now we're going to change it up. I'm going to ask what percent of the final amount is pigment. Okay, so same two cans. One is 12%, one's 30%. Okay, so I'm looking back over here at the cans. Same two cans. And what percent of the final amount is pigment? Well, you may remember that there is 16.8 ounces of pigment. And how much paint? Well, remember there is 40 ounces here and 40 ounces there. Okay, so what I'm going to do is say, look, there are 16.8 ounces of pigment in 40 ounces of paint, and we'll just calculate that as a percentage. Okay, so I paused the video and got 0.42, so 42% pigment. Okay, that can't be right. Okay, so yep, if you were in my classroom, you would be used to me every once in a while making some goofy mistake, and usually I catch it or somebody else catches it, but not always. Maybe you caught it and there's nothing you could do because you're watching a video. There's actually 80 ounces total of paint. So we have 16.8 ounces of pigment out of 80 ounces total. And if I recalculate that, I get 0.21 or 21%. Okay, I paused there for a minute and thought that can't be right because I knew one of them was 12, the other one was 30. The mixture has to be somewhere in between there because the lower concentration is going to dilute the higher concentration, and the higher concentration is going to strengthen the lower concentration. So I knew it had to be somewhere between 12 and 30, and so when I got 42, I paused. That's what that pause was about. So, hey, that stuff happens. I'm not going to worry about pausing the whole video and starting over just because of that. Life is like that. Okay. So I'm going to go on here. I'm going to change it up again. Now I'm going to say what percent of the final amount is pigment, and nope, that's the same question. Okay. We're now going to look at rubbing alcohol, and we're going to ask the question, what if there's a 20-ounce bottle that's 40%, and a 140-ounce bottle that's 80%? Okay. What percentage of the final mixture is alcohol? Well, let's grab our little diagram here. I went ahead and just made them flat so you could see them a little bit better. Okay. So I got two bottles. Here's one that's 20% and 140 ounces. Not sure what happened there. There you go. 140 ounces. And I had another one that was 20 ounces of 40%. Okay. So first what I need to do is figure out, well, how much pigment is in each one. Okay. Well, to do that, what we'll do is say, let's find 20% of 140. Okay. And 40% of 20. Okay. So the purple is how much alcohol is in the first jar over here. This red is how much alcohol is in the second jar over here. Okay? And the total amount of alcohol is what we're going to get when we add these together. So 20% of 140 is 28. 40% of 20 is 8. When we add those together, we get 36 ounces of alcohol. Well, that's not the answer. What we want to know is, what's the final concentration? What percent of the final mixture is alcohol? Okay, so this is 36 ounces of alcohol out of how much mixture total? Well, I've got 140 there, and I've got 20 there, so 160. Okay, so now what we'll do is calculate the percent. 36 divided by 160, and I get 0.225. So final concentration must be 22.5. Wow. Had a little disaster there. I'm back. That's what I get for trying to write on a tablet. Okay. So 22.5%. Okay. So when we mix 20-ounce bottle that's 40% and a 140-ounce bottle that's 80%, we get 160 ounces. That's 22.5%. Okay. Let's do another one. We're going to mix cereal this time. Okay. So we'll grab our diagram. Over here, maybe make it a little bit smaller. Okay. And we'll copy it. All right, so we've got 42 ounces, that's 8%. Okay, and we're using the same diagram, same idea here. So we got 42 ounces. Okay. Okay, had a little technical problem. Trying to get rid of that mess there. Okay, so we had a 42 ounce box that's 8%. Okay, and we had a 84 ounce bag. Okay, that's 20%. And we want to know what is the final concentration of sugar. This should say sugar here, not cereal. Final concentration of sugar. Okay, so we're going to have to figure out what's 8% of 40. That's how much sugar is in the first one. And what's 20% of 84? That's how much sugar is in the second one. And add those together, and then we'll divide by the total amount of cereal. Okay. So let's see what we get. 8% of 42. Okay, and that is 3.36. Okay, and 20% of 84. Okay, that's 16.8. Okay, and then the total of those two is how much sugar we've got. So 3.36 plus 16.8. Okay, I'm getting 20.16 ounces of sugar out of how much total? Well, I got 20.16 out of 42 and 84. So combined, that's 126 ounces of cereal. So we'll calculate the percentage from that. So 20.16 divided by 126 ounces is 16%. Okay, so I'm hoping you're getting the idea. Okay, so we can also mix people. Okay, and I think what I'm going to do is, instead of drawing the diagrams anymore, I'm just going to say, look, let's just make our own here. And we've got 12,000 people in the first city, and that is 40% Democrats. Okay, In the second city, we've got 9,600 people, and that's 22% Democrats. Okay? So I hope you're getting the idea that basically what I have to do is calculate how many Democrats are there, how many Democrats are there, and add those together and divide by the total number of people. Okay? So we could actually just write this out. We could say, well, 0.4 times 12,000 plus 0.22 times 9,600. Okay? And then divide that by the total number of people, which is going to be, 21,600. Okay? And then we'll calculate all that and do the division and write it as a percent. I paused the video while I did the calculation, and so when I did that division I got 0.32, so 32%. So when you mix the two cities together, they're 32% Democrats. Okay. So here's the idea. When you're mixing these two amounts, you got whole things that you're mixing, and there's stuff mixed into them, like concentration or Democrats or rubbing alcohol or paint pigment. So what you've got to do is find and add the amount of stuff that's mixed into each one, okay, and then divide it by the total amount of stuff that's being mixed. Okay, so if I was mixing two different kinds of paint with different concentration of pigments, the first thing I've got to do is figure out how many ounces of pigment are in each one, add those together, and then divide by the total amount of paint. Okay, so I think I've got another problem here we can look at. So let's do another one. I've got 112 tons of metal. That's 18% aluminum. Okay, and I've got 78.4 tons. That's 52% of aluminum. And I want to know what's the final concentration of aluminum. Well, I think we can figure this out without diagrams now. Here's 18% of 112. Okay, that's how much aluminum is in the first part. Okay, and I've got 0.52 times 78.4. That's how much aluminum is in the second amount. Okay, so when I mix these together, I'm basically adding up this amount of aluminum and that amount of aluminum. Okay, so I've got the total amount of aluminum there, and then I'll divide by how much aluminum there is total. So I've got 112 plus 78.4. Okay, adding that in my head, not always reliable, but I think I'm getting 190. No, sorry. Wow, 180. Yeah, 190.4. Got that? Took me a little while. Okay, so 190.4. And then we'll just do this calculation and see what percent we get. I get 0.32 when I'm all done. So 32% aluminum is the final concentration. Okay. So kind of a quick final note here. Why are we doing this mixture stuff in an algebra class? Well, as we move along, when you get to part 2, we're going to ask the question backwards. Instead of mixing together two things that we know, we're going to work backwards. We're going to say, look, when it's all said and done, I want 12 gallons of paint that's 12% pigment. Okay? All I've got is paint that is 5% and paint that is 20%. Okay? So how much of each of these do I need to mix together so that I get this amount that I want? And that's going to be the kind of question that we're going to use. And when we do that, we'll end up using the skill that you've developed before called solving a system of equations. Okay? So that's where we're going. Okay? Until next time.